Hey everybody, it's Mrs. C, and I'm here with my Pumpkin Patch Challenge problem over from EduCreations, where many of you have been actually trying the Pumpkin Patch Challenge and possibly having a hard time and not even knowing it, because back in the day when I posted this, I didn't post any answers. So I wanted to go over it with you briefly and make sure you do know what you're doing and maybe explain it a little bit. So in the EduCreations video, if you watched it, it's short. I give you about 4 problems, I think, and you can see number 1 in interval notation. These are compound inequalities in interval notation, and I ask you to graph them and then write them in set notation, I believe. So you're going to graph them and then write them in set notation. And then the extra catch is I'm asking you to write each one of them as not just an and in this case, but then also an or. I want you to really experience what it is, the major differences between graphing the same data, but as an and versus an or. So that's pretty much the challenge. I think we'll just get started, jump right into it, and see where we land. All right, for number 1, we have a graph that is asking us to work with the numbers -2, 5, and then the infinities. So let me just draw my graph that would show always 0, my 5 on the right, and my -2 on the left. Now, I am first going to notice that I am supposed to be graphing from -2 to infinity, and it is a open interval, so it would be a parenthesis, and I am shading towards infinity, which is to the right. The other one is telling me I should be going from -infinity, which was, I was almost there. Let me do a different color here. I'll use an obvious different color. Obviously, a different color would be maybe green. Okay, so I am going from -infinity to 5. Now, negative infinity, I can't trap negative infinity, so I'm just going to start out here in the negative infinities and go from 5. Or you could do it this way. You could say from, from 5 onward to negative infinity. Maybe that looks a little bit better. Now, if I am graphing an and, trying to use as many different colors as I can, an and is asking me to show a final graph wherever there were both colors. So you see black and you see green in this case. Where do you see black and green? Hear the word black and green. I see black and green in between here. All right, I see black on the right, I see green to the left, but I only see black and green in the center. And so it's always important to do a final graph. So let me show you the final graph. That's not a very vivid color, is it? Let me go back to black. The final graph would show the 5, of course, and it would show the -2. Stem is in the way, and it would go from but not including the -2 to the 5 and not including the 5. That's what the parenthesis means. All right, that's the graph of the and. Now let's take a look at how you would graph it as an or. You just have to come back here. Change the word and to what word? Yes, change the word and to or. Or is asking me where on the graph that I've already graphed do I see black or green? Hear the difference? Where on the graph do you see either black or green? Now I see black all the way out here into infinity, right? Well, maybe a bad choice of color. Let's go back to the red, huh? I see black over here from infinity. Infinity coming into 5. 5, I see green. Then I see black and green, black and green, black and green. Now, is it okay to see black and green? If you see black and green, do you see black or green? Yes, you see one or the other, you just get the added bonus of seeing both of them. Ors are less discriminating. They just want to know wherever there was color or shade. And here I come past the -2, which was in black, and then green, green, green. So the answer to the question of where on the graph do you see black or green is everywhere. I see it everywhere. And then, therefore, the graph of the or would look different than the graph of the and. So sorry, those colors aren't showing, are they? 0, 5, -2. I saw color everywhere, and therefore my answer, what is it when you graph everything, is all real numbers. Now that's my set notation. So here you have, guys, what would we call this, a rough draft possibly? A rough draft graph? Rough draft graph. I sound like Scooby-Doo. Rough draft graph. Rough draft graph. And then over here on the left, you see the final graphs. You see the graph of the and, which was this one, and then the graph of the or, which is that one. All right, let's move on. Now, let me just use my eraser so we can see. Oh, look at there. That was that little pumpkin. And then I just want to get rid of what we're currently looking at. Just so, oh boy, that's going to be a little trickier to get rid of, isn't it? Okay, well, I got rid of it, but I didn't have time for detailing, so it's gonna have to be just a big old mush of, it looks like the pumpkin got squashed, right? All right, let's graph this next one as an and as an or. So here is my and that's, I'm starting with an and because it's an and. Now I'm going to go with a different color because I felt like maybe it would have been better had I used two different colors when I was doing this. So my first graph, I need to see a 0, always a 0. On the right I have my positive 6, to the left I have my negative 1. You know where the infinities go. Now, the first, this one, let's go with, again, another color because I want to show you the different colors. Over here I have, I'm going from negative infinity to 1, negative 1, excuse me. So it would look like that. Then my other side, let's go over to like a blue, possibly a nice blue. I am going from negative infinity to 6. Both of them coming from negative infinity. One's going further than the other. All right, so something like that, right? Okay, here go the questions. The first question is the and, right? Yes, the first one it gives me, let me use my black now. The first one it asks me is the and. Where do I see both green and blue? I see both green and blue here. And therefore, my answer as an and, I still like to put my 6 and my 0, but they're not part of my solution. The only solution for my and is this. Now what about my or? Change the and to an or, ask yourself the same question, but this time it's where do you see blue or green? Where do you see blue or green? Well, I see blue from the 6 all the way to the negative 1, then I see blue and green all the way out from there. So where do I see blue or green? I see it from the 6 all the way into negative infinity. This is my and, this is my or. Okay? Pretty straightforward. Let's try another one. Okay, here's pumpkin number 3. So first I want, always, to draw my, that's a pretty big line I wound up drawing. That was a bigger font than I meant to do. Try it again. Okay, much better. First thing I'm going to do is I'm going to graph my numbers. 0. Okay, didn't have a whole lot to do on that one. 0. Now, I'm going, firstly, let's say in green, I'm going to go from negative infinity to 0. All right, so there you go. There's negative infinity to 0. The next one, and I don't know if anybody noticed, I just want to draw attention. This is an or. If you notice, my little symbol that I'm starting with is an or. Now I'm going to go from, let's see, I'm going to go from 0 again to infinity. Oh, well, isn't this fun? Different color. I'll go with red. It'll be red and green, very holiday-like. And there we go. That's what this graph looks like. Whether it's an and or an or, it doesn't matter, does it? Okay, so This is a cute one. If I'm going to ask the question, what's the question? Well, first I'm going to start with the or this time because it is an or first. The other times I believe they were ands first. My question is, where on the graph do you see green or red? And it almost looks like everywhere, doesn't it? Except let's just investigate what that means. The parenthesis is an open interval. It means, remember the open circle? It means you don't count whatever it's on. So it's up to, from negative infinity, up to but not including 0, and then from 0 but not including it on the red all the way to infinity. What does that mean? It means your solution set for the or looks like everything except what? There's this big open space on 0. There's this big protective bubble on 0 that's saying everything on the graph but not 0. And that in interval notation would be written just like it was given to us. In set notation, you could say all real numbers, however, you could say x is not 0. Okay, so that's kind of a cute one. It's a little trick. So you're asking maybe, do I have to use the open circle that looks like a little force field that's protecting 0? Absolutely. You could use a 0, an open circle. You could use the parentheses, just like you see here. There's nothing wrong with it. I just want to make sure you understand it. Now, if we had to graph this as an and, what would we change? Well, we would probably change a whole lot, right? They seem to always change quite a bit depending on what they ask. So let me just get rid of this for a moment. In fact, I'm just going to, normally I don't erase my rough draft graph, but I felt there was just a little bit too much going on there. So here we go here we go here, and if you recall, I hope I'm doing my colors right, it was a shade that way in green, and it was a shade that way in red. Okay, so the question then is, if we're talking about an and my question is, where do you see both red and green? Then what is your answer? Where do you see both red and green highlight? Well, you don't. Here we only see red, 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 switch, green, green, green. You don't see red and green here, because the parenthesis means I'm not really here. I'm showing you where my line would stop, but you can't include where I'm stopping. That's what an open interval means. Remember the protective shield. So the answer, if this was an and, is that there is no solution. And so for my and, I would have to use my null set. All right, I have one last pumpkin to do, and then I have to get ready for school. I gotta get to you guys so that I can teach you more cool and amazing things. So hopefully I didn't save the hardest for last. I don't remember. It's been a long time since I did the pumpkin patch pictures. So let's start with the graph. That's what I always do. There we go. I'm supposed to be doing an and first. I like to put that there so I don't forget. So I have 3, negative 3, 3, 6. So 0, I have a negative 3, I have a 3, I have a 6. There's a lot of numbers involved here. Let me see. Excuse me, I hiccuped. What color shall I use? Let me use brown. So I'm going from negative 3 to 3 with brackets. Okie dokie. That was pretty easy. And then let me go white. I'm going from 3 to 6. All right. So from 3 to 6. Okay. So if this was an and, I went from negative 3 to 3. Inclusive. I include 3. That's what the bracket means. It's a closed circle. So I am going from negative 3 to 3, including 3, and then from 3 again, including 3, I go to 6. So if this was an and, where do I have both brown and white? Do, 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 do. Where would I have both brown and white if this was an and? Do you know what the answer is? you, I hope, are right. 3. You only have shade on the number 3. I like to go back, be a little retro here and use a solid closed circle because I find it makes more sense. It looks better than just a bracket. I guess we could do a bracket on 3, but that just looks strange to me. So the answer there, the only place I have double shade is on the 3 itself. Now, let's go back and look and ask the question, where do you see brown or white? Brown or white? I'm losing my voice. Okay, I'm going to redo this again. Well, I see brown or white everywhere from the 3 all the way to the 6. And so that would be my or. Now, doesn't that or, I just have to say this, doesn't this or look like a graph that you would normally represent using ands, or what we would say interval notation, that would be an and, because it appears as if the graph is shading towards itself? And the answer is yes. Sometimes when you graph an or, and it's, what would we say? It's not simplified, possibly. It's an unsimplified interval notation. Then the final interval notation would be written in a simplified form. Now, I know that's a lot to, sorry, I'm just going to multitasking here because I'm almost done and I want to bring it home properly. When I graphed this as the one that I asked you to graph it, which was as an or, the graph looks like this. How would we write that in simplified interval notation? Well, pretty easy, right? It would be like that, which you already know. But did you know that you can have one written like that, that after you graph actually is written like that? Oh, yes, you can. So you always, what's the rule? Always graph everything on a graph before you write its final answer in either set or interval notation, because the graph itself is the final view, and then you want to write your final simplified answers in their final simplified form. That's it, guys. That was the Pumpkin Patch Challenge. I hope you enjoyed it. I hope you did well. And most importantly, I hope you ask questions when I see you on the flip side. Later.